All right, let's try it now. Give me 1 second. It should start showing up any minute. Okay, there we go. All right, guys. Let's give a couple more minutes now for everyone to trickle in. Manny, let me know if you can hear me and all that good stuff, so make sure my technical side of things is going on here. So I've already started a surface chart this morning. I hadn't even finished it. I've got a lot going on. This was from 14Z, so that would be from 9 a.m. and now it's approaching 16Z, 11 a.m. So I'll probably have to print off another one. I plan on meeting my chase partner, the guys that are going with me today, around noon here in town, and then we'll probably position somewhere where we can get ourselves in position to move any direction we need to once the targets become clear. Obviously, I'm alluding to I haven't picked my chase target yet today because the atmosphere is in transition. We've had storms, we've had more stable air move in, and that cooler, more stable air is going to be moving out today. It's going to be replaced by very warm and unstable conditions. It's going to feel kind of like mid to late May out there again today. So let me see here real quick. I've got visible satellite up, and we're going to talk about this here in a minute. I've got it on kind of a slightly wider view, but let's go ahead and dive into this, I guess, here. I do thank you guys for joining me today. It's coming up on 11. And today the severe weather risk has been well advertised for a while, so this isn't anything that should be a surprise to anyone that we're going to have severe weather today. So anyways, before I get started, so I'm going to give out a shout out to Tornado Place Storm Shelters. I'm sure they are busy with all the tornadoes that we've been having this year and continue to have. People are obviously very aware of the threat. It's a very real threat in this part of the country, and I've got one in my garage. It's an excellent safe room. I have plenty of room to get everyone in my house in the safe room. I've got how many people are living under my roof now? 6 people living in my house, and we've got plenty of room for them, and we'll probably get some neighbors in next door, and we can still put 2 cars in our garage. So they're excellent design. They exceed industry standards. They exceed the EF5 certification requirement as far as the gauge of steel and the anchoring. It's an incredible design. It's a modular design, very strong. I mean, even a tornado like that hit Enid the other day, I know my family, if they were in a tornado of that caliber, we're talking a violent EF4, borderline EF5 possibly, I know that even if our house was completely swept away, that they would be fine in that safe room. So if you're looking for a safe room, you're in the market for one. There's a lot of people that sell safe rooms. Not all safe rooms are created equal, but I guarantee you're not going to find one built better than Tornado Place. And Roger and his team, they have integrity that's hard to find in the world today. They do an honest job. They do timely, quick work. They're fair on their pricing. They clean up after themselves, so you're going to get a safe room in just 2 or 3, 3 to 4 hours. You can have one built. Sometimes it's very simple how they do this, and it's very effective. So if you're in the market for a safe room, check out tornadoplace.com. So now we're going to get into the forecasting because everyone wants to know what's going to happen today. Me too. We all want to know what's going to happen today. We've heard a lot of talk about some big storms coming, and now this is the day of, and so let's get into what's happening here. So I've got visible satellite up. You can see Oklahoma here. in the center of this map here. We've got a lot of clouds over Oklahoma right now, and you can see though that those clouds are starting to erode some, and they're also lifting north, while clouds over the top of them are moving from west to east. So right there it tells me we've got a lot of wind shear in place today, because we've got clouds moving in different directions at different altitudes, and so we've got wind shear. So kind of to give you all kind of fill in on what's happening here. We've got a warm front that extends roughly down through here, the southern edge of this low cloud bank. So this is from far southwest Oklahoma down along the Red River into North Texas, north of the Dallas metro, but between there and like Durant or Ardmore, like that's where that boundary is lifting through. And this boundary is expected to lift somewhere up into south central and southeast Oklahoma by this afternoon. And that boundary is going to be the main focus for severe weather today. There is another boundary that has been showing up in some of the data, possibly extending here through northeast Oklahoma, possibly down from maybe Osage County, Tulsa County, back down through maybe Muskogee County. I need to look at this a little bit in greater detail to see if that's something that'll be a player. The HRRR, I think also the NAM3K, were all kind of bullish on a secondary zone for supercell development, maybe through northeast Oklahoma. And I still think the highest threat is going to be on the warm front, and this is probably where the highest tornado threat is going to be. So right off the bat, I'm kind of telling you what my initial thoughts are, that the highest tornado threat is probably going to be I-40 south, down maybe just south of the Red River. So this zone is southeast, south central Oklahoma, so south of Oklahoma City, south of Henrietta, south of Fort Smith, be like McAllister, Ada, Duncan, Ardmore, Durant, Pauls Valley, like that, those areas through there, and then into northeast Texas this evening. So this area is all socked in with clouds right now, but these are mostly low clouds. You can see we've got a few high clouds streaming across west to east, and that's with the jet stream. Those clouds are a little bit thicker here, but they're moving quickly off to the east. And back to the west, it's pretty clear. We've got sunny skies over the, actually, am I on, I want to do true color. Hang on, I'm going to switch this. I like true color better. This is a more natural representation of what it looks like. So you can see skies are clear back across western North Texas. They're clear across the Panhandle back into the high plains. So the air out here is going to get very, very hot today. And it's dry air out here because we have a dry line that's situated from, maybe far southwest Oklahoma through the western hill country of Texas, probably just to the east of the Caprock. And that boundary will sharpen up today. It may advance east a little bit into maybe southwest Oklahoma, west of the Dallas-Fort Worth area, also as that warm front lifts north. And as more energy comes out from the Rockies, we've got, jet stream disturbance aloft that's coming out through the southwest U.S., southern Rockies. And that's where these high clouds are preceding that. And so as that energy comes out this afternoon, late this afternoon, this evening, that'll help foster these thunderstorms to develop. And the way the atmosphere looks today, in fact, let's go back to switch my sources. Give me 1 second. 4S tools. I'm kind of diving into some of this right now with you guys. Share this tab instead. So yeah, we're lacking a lot of data here. I'm not going to get into that. I started a whole feud on Twitter the other day. Didn't mean to do that. I was just lamenting that we need sounding data. I mean, we've got, you can see on this map, each one of these stars is where they've released a weather balloon. And for my 30 years of doing this, these weather balloons have been released all over the United States, and every day at 7 a.m. and 7 p.m. And then on severe weather days, you get special soundings at like 1 p.m., sometimes 3 or 4 p.m. too. So with restructuring of the Weather Service and government cuts. We're seeing a lot of people retired in the Weather Service, and they're trying to hire new people. So we have a lack of people to be able to release the balloons. These balloons are very, very important, especially the morning ones for the model data that we get every day. So you can see there's a big hole in the data here. And so we don't have a lot of information that we could use. And so it makes forecasting a little bit more challenging. There's ways to work around it, but I think we have in some way seen a reduction in some of the forecast skill recently because we're not getting as much sounding data. So I'm not trying to get political on anything, but gosh, it seems like our government, no matter who's in power, they can fund missiles across seas somewhere, but we can't even get weather balloons here. So I'm done screaming about it. It's frustrating. We need this data. We will get data later. A lot of these places, they've supplemented. Instead of launching at 7 a.m., they're doing it at 1 p.m. That's good in itself, but it would be best if we had both, and we don't. So the 7 a.m. data, the models that have run this morning, they're missing some important data. There's other ways that they get some of that, but these weather balloons really are critical. And but I'm going to use what I've got here. So we've got super steep lapse rates on the Midland Odessa sounding this morning. For those of you that are not big into the weather stuff and don't understand all this, just kind of bear with me. It just means the atmosphere is conditionally very unstable. It means the air gets really cold really quickly as you go up in height. And there's a layer of warm air about a mile or so above the ground that's kind of a lid. And today that lid doesn't look particularly strong that it's going to limit storms. It looks like it could be easily breached. So we're going to have quite a few storms today. And we've got enough wind shear to go along with the extreme instability that's present. In our moisture depth here, it's really good down here in South Texas, but our moisture depth here up through about 1 kilometer up above the ground, it's good, but it's not incredible. I mean, there's quite a bit of a drop off here, but it's still adequate for sure, and we're still going to get a lot of instability. We've had a lot of rain, so you're going to get the vegetation when the sun heats it up, like after you've received a lot of rain. There's a lot of evaporation of that humidity into the air. We call it evapotranspiration. It's part of the water cycle. And so as plants release all that water content into the air, it's going to spike the humidity today. So we will see dew points pushing 70 degrees in Oklahoma today. 1 second. Anyway, so a lot of potential instability there. I'm going to show you real quick. Let's switch to this. I'm going to show you guys the risk area today. So here's the risk area. So this green, the light green is just where you expect general thunderstorms. The dark green is a level 1 of 5 severe weather risk. Yellow is a level 2 of 5. Green is a level 3 of 5. And red is a level 4 or 5. And then the next one is pink, which is the high risk. It's a level 5 of 5, which is the highest level. So we're like at DEFCON 4 today, if you will, in central southeast Oklahoma. And then Tulsa, Oklahoma City area, you're more like in a DEFCON 3 type of thing going on. So we've got a really heightened risk for severe weather in central and eastern, southeastern Oklahoma. And tornado threat today, this is the current risk. So this is the risk of seeing a tornado within 25 miles of any point in that area. So within 25 miles of Tulsa, there's a 5% chance of seeing a tornado today. Down here, you've got higher chance. 5% doesn't sound like a lot, but when you add up all this area, it basically means someone's going to get a tornado today. That's kind of what they think. And then the hatching here means that there could be EF2 plus strength tornadoes. So we could have a significant tornado threat today. What's really driving the threat, though, it's not wind. We do have a heightened threat for damaging thunderstorm winds. And this area down here is especially true because We expect the storms to cluster this evening in this area, and when storms cluster, they transition from a hail and tornado threat to more of a damaging wind threat. So that's why this is highest and extends further southeast there. And then the hail threat, that will be with the initial supercells. And you can see here we've got a max level intensity with a 45 probability hail threat. So we're expecting hailstones 3 to 4 inches plus in diameter. We could see softball size hail today with the most intense storms. And again, that risk is highest generally like I-44, I-40 south down to the Red River. But even here in Tulsa, we have a threat for potentially destructive hail, golf ball, tennis ball size plus, especially if we get a supercell across the city. No guarantees with that, but that is a potential here. So those are the actual risk area according to the Storm Prediction Center. One of the other things I'm going to look at is just quickly switch to the Oklahoma Mesonet. So I'm looking at the current conditions here at 11 a.m. And here in Bixby, we're 66 degrees with a dew point at 59. Same in Tulsa, 67 over 60 down here in the Haskell, Porter area. You go down here to southern Oklahoma, though, we're down here right on the Red River. We've got temperatures in the low 70s and dew points in the mid to upper 60s. So we've got more juice developing down here, that nadir juice, if you will, that heat and humidity that these storms thrive off of is obviously going to build down here first because that's where the true warm front is lifting through. In fact, I would argue that warm front now is lifting north of the Red River into Oklahoma. So we'll see how far north that makes it by the time we get storms, because that warm front lifting north is going to be the focus where most of these supercells, or the most intense supercells, are expected to develop along and track. And what happens is this boundary, it separates slightly cooler humid air from very unstable humid air. And winds north of the boundary are what we call backed. They're more out of the east-southeast. Winds south of the boundary are more veered. They're more out of the south. And so you get air that comes together at the ground, and when that air hits, it has to rise. But then you also get rotation along that boundary, and depending on how that rotation aligns into the storm, if it's favorable, then that storm can ingest that and become tornadic. And obviously we saw the other day what happens. Brandon, today's done. Okay, sit down, Brandon. He's being silly over there. I got my buddies on our chat. We're all goofing around talking about the weather because that's what guys do that chase tornadoes. But anyways, we have a heightened threat of severe weather today, especially along that boundary. Storms will develop along the boundary. They'll anchor to it. And then anywhere where a storm is getting humid air feeding into it, that's where a storm could potentially produce tornadoes. I think the threat up here in northeast Oklahoma is maybe a little bit lower, but it's definitely not zero. In fact, I would say it's not it's definitely like a higher than zero, like very low end threat. We've got a slightly heightened threat up here, especially if there's a boundary that shows itself where storms can anchor along. But again, the highest threat, and probably where I am taking my talents today to go storm chasing, is going to be down here in south central to southeast Oklahoma, maybe around the Ada area down to Durant or Durant, depending on how you pronounce that. But I'm kind of favoring this area where the higher instability is. Because these storms will be moving southeast, it makes for very tricky storm chasing because the navigation with southeast moving supercells is a whole different animal than east or northeast moving storms. These southeast moving ones tend to be a little bit more rain wrapped. It's a lot harder to see the tornadoes, and a lot of times the inflow notch, which is where you have clean air feeding into it, it's pretty tight, and there's not a big window to get in there and get a good view of it. And when you got a lot of chasers on the weekend in Oklahoma on maybe one or two storms, and they're all vying for the limited road options that you have in southeast Oklahoma, it makes for some white knuckle storm chasing. It's like a bottleneck on Everest with an incoming storm, with the climbers that climb Everest. You just find yourself in a really bad situation. You can't go anywhere, and you just have to ride it out. So People will probably lose some windshields today in the storms. I hope I'm not one of them because it costs money to replace them. But the hail's going to be big enough that we could definitely see some chasers losing windshields. So, but let's go into some of the model data real quick. I'm going to start with the NAM on what it thinks is going to happen with some of these surface features, and then we'll get into some of the cams here. So this is the 12Z. So you can see this is an hour ago. It shows that warm front, the magentas and these blues, that's where the deeper moisture is. The greens where the not as deep moisture is. And so you can see that surge north. This is at 1 p.m. That's at 4 p.m. And then this is at 7 p.m. And so you can see this tongue of instability, and you can see that line through here. If I zoom in on this a little bit, you can see there's this kind of this zone. That's the actual effect of warm front. And so when you got a warm front and you've still got some high humidity on both sides of it, that's a pretty good boundary to be on. So you've got kind of a dry push nosing up in here, and then so your dry line's here, and then you've got a bit of a cold front up here, so you get an effective triple point. So this area just southeast of Norman down towards Ada seems like a really prime spot. The big question is, how long can a storm remain discrete enough but also have clean enough inflow where it can get become surface based? There's some of the data that's suggesting a lot of these storms will be slightly elevated. So that's an uncertainty with the tornado potential. The other uncertainty is how the low-level shear will be oriented to the storms, the way in the direction that they're moving. Tornadic rotation starts off horizontal. If you've got your storm updraft, you want that rotation going into it streamwise, like basically where the length of it is feeding into the storm. If it's laying across it, where it's crosswise and the storm goes over to the top, it's less favorable for tornadoes. And so there is concern that the way the boundary is oriented and how strong the winds are backed behind the boundary versus how veered they are, especially as you get up above the ground, that there's too much wind shear. If you've got winds coming opposite, that's too much wind shear for tornadoes. Tornadoes like about 90 degrees of turning. That in fact, 90 degree is what we consider the critical angle for tornadoes. A lot of tornadoes happen at less than 90 degrees, maybe as little as 50 or 60 degrees of shear, and they can happen as much as maybe 120 plus degrees of wind shear. But when you get like 180 degrees, it'd be way too much. But we may be on borderline with too much directional shear that we don't get favorable trajectories for that rotation to get into the storm and really the storm take advantage of it to make a tornado. Because getting a tornado is a process, and it's a well-oiled machine that has to work good enough, long enough to make a tornado. A lot of storms try to make tornadoes, but they can't sustain it long enough to actually get it there. So that's what a lot of times what tornado threat hinges on, is a balance that lasts long enough that you can get the circulation to fully develop into a tornado. It's just like your little whirlpools in your bathtub. Kids like to watch the little whirlpool spin up at the drain. A lot of times it shows up and then it disappears. And again, it's just all about balance. The atmosphere same way. So the greatest threat though would be along that boundary, especially wherever it's oriented favorably for a storm to get that rotation favorably ingested into the updraft. And then if that's the case, then you would have a significant tornado potential, because the atmosphere is going to be extremely unstable, meaning that the air is going to rise really fast. I mean, imagine a hot air balloon on a really cold day, and you just crank that burner up, that hot air balloon would just take off. And that's kind of how the atmosphere is, because we're going to be really hot and muggy near the ground. We're going to be really cold and dry way up high. And so the air is going to want to rise very quickly. And when you create a vacuum like that, it's real easy to get spin to stretch and become a tornado. So that's the thing that really kind of enhances our tornado threat, plus the shear. It's just, do we have too much shear? Will the storms be too messy? And will we have too many storms develop at once? So those are question marks that we just don't know until the storms start developing. But again, there is a enhanced and moderate risk. I know that the names of these risks are kind of misleading. You would think enhanced is higher than moderate, but it's actually the other way around. Moderate, because that name's been around for decades. As they've upgraded these scales and recategorized things, they've kept some of the old naming. And moderate used to be a level 2 of 3, high being, it used to be slight, moderate, and high. But now they've added marginal, slight, enhanced, moderate, and high. So moderate probably should be a 3 of 5, because moderate would be like mid, right? And then enhanced being a little bit higher. That's the Justin T. He doesn't know I'm on the thing. I'll call him back in just a second. That's my homie though. So I am going to wrap this up pretty quick. But anyways, expect storms to develop today, somewhere at 3 o'clock maybe at the earliest, but probably more like really taking off after 4 or 5 o'clock. And when they develop, they're going to go really fast. I mean, it's kind of like what happened the other day with the Enid storm. It exploded really quickly. I mean, it was like nothing to tornado. I don't know if it took an hour, maybe. I don't know. It was really pretty quick. I'm sure someone knows exactly how quick that was. I wasn't on that storm. I was on the one up north that tornadoed. But still, even that storm was fairly quick with how it developed. It took a while for the meso to get going, but the storm went up fast. And today, I would say, like today, the storms will go up probably within 30 minutes. Like it'll just be an atomic bomb in the sky when they take off. And the severe weather threat will ramp up very quickly within that first hour of the storm showing up on radar. It'll already be producing giant hail today. So big hail is the biggest threat. That threat does include Tulsa. If you get any storm developing over Tulsa, I would just treat it like it has a hail threat and have your cars in the garage or have your vehicle, you can find parking garages, awnings. You can go to banks. You can go to car washes are great. Do not park under overpasses, though. Do not stop on the highway. I mean, if you're in softball-sized hail, I can't fault you for stopping under an overpass. But the thing is, what you have to realize is you're blocking the road for everyone else, including emergency vehicles. And what if you do that and there's a tornado coming and you don't realize it and you've just gridlocked everyone right in the path of a tornado? That hasn't happened yet, and I shudder at the thought of the day that does happen, because it just seems inevitable. And people keep sitting under overpasses, blocking up the highways. First responders can't get through. Storm trackers that are tracking the storm, trying to get, information back to viewers, we can't get through. And then it creates the potential for accidents, because, generally you don't expect to see cars blocking the interstate, or the highways. So that's one of those things. Just please do not seek shelter under overpasses. But again, one final recap. The severe weather threat will pick up this afternoon, probably after 3, 4 o'clock. It'll probably maximize very late this afternoon, early evening. So 5, 6, 7, 8 o'clock. That's that window when the storms will be most severe. I do think the highest threat for the most intense storms will be on wherever that warm front sets up, most likely along or south of I-40. And then there may be a secondary zone up into northeast Oklahoma somewhere, possibly in and around the Tulsa area. And again, very large hail, damaging winds, and even a tornado threat possible today. And one last thing I'm going to do, I'm just going to see this latest run. Let me switch tabs here. I'm just curious what the latest HRRR. So it thinks this boundary is going to it does deepen the surface low out there in northwest Texas or southeast Texas panhandle, and it lifts that. It kind of holds serve on that boundary. It doesn't lift it too much further north. It kind of gets it into Oklahoma, and that's about it. Let's see. And it pops off storms kind of the same. It's got the same general idea. I'm going to zoom in on the Oklahoma part of this map now. All models are useful. No model is correct. Like this is not going to verify exactly the way it shows. But it probably will have a pretty good handle. And it's been very bullish in these two zones. It's kind of shifting this one. So Tulsa's right here. Last night and earlier it had it more like up through here. Now it's kind of shifting that maybe just slightly south, even developing those storms more intensely down closer to I-40. This storm here is an absolute hog, and I guarantee there's going to be a hail threat with it. There could be a tornado threat though early on, especially down here. Again, wherever this develops, it could develop over here, it could develop back here, it could develop up here, it could develop down here. We don't know the exact location, but the way the helicity track looks on that storm early to late, it looks like there's a skinnier helicity track, which is more of like a tornadic type circulation versus a fat helicity track. And when I'm talking about helicity tracks, I'll switch. So this is where this model is trying to depict storm rotation. And you can see the scale is down here. So obviously this is the high end of the scale, meaning like intense rotation. This is the low end of the scale, meaning weak rotation. So obviously we look at this, it has the highest rotation all south. Here's Tulsa, here's Oklahoma City. So it's pretty much southeast of the I-44 corridor, more closer to I-40 and points south. So I-35, South Oklahoma City, I-40, that would be like Henrietta, Chakotah, maybe down towards McAllister, Eufaula, Stigler, maybe down towards Poto. I mean, if you take this model verbatim, again, this could end up over here, could end up right in the metro, it could not happen at all. It'd be all the storms that do anything end up down here. But I think from a storm chasing perspective, you want to be on storms early. That way you can position on them, but you also want to be on them whenever that, if they develop a tornadic window, you want to be there when that tornadic window develops, whenever it may be. And it may be short-lived because we're dealing with a lot of storms developing in close proximity, and then maybe wind shear orientation that's not quite favorable for tornadoes. So we'll just see how that plays out. But again, you're anywhere outdoors today, you're anywhere, going to be out and about this afternoon, late this afternoon, this evening, even here in Tulsa, even though all this data shows it's south right now, we don't write it off because we don't know exactly where it's going to happen. This model may be completely off. It may, in a couple hours, start showing everything right in the middle of the city again. But if I go back to last night's run, there's last night's run. So this area, it's still on it. This area, and it's still kind of on this area, but it also had something up here. Now it's backed off of that, obviously. 12Z run looked like this. It was at 7 a.m. So this model updates every hour. And so the most current one, it has it all down here. So, anyways, I appreciate you guys tuning in. If I get on something interesting, I'll probably fire up the live stream again here on Facebook so you guys can watch that. The other day I got to stream a tornado from birth to death, about 50 minutes of streaming during a tornado intercept. We got within about a half mile of the tornado, maybe 3/4 of a mile, half mile. We could have got closer. We didn't, but it was still an incredible chase, and fortunately, nobody died the other day, and I'm hoping that we can avoid that again. And we'll deal with tomorrow's forecast. Very high ceiling tomorrow, but low probability, especially further south here in Oklahoma. The main threat may be up in Kansas tomorrow, and then that threat shifts into Illinois, the Midwest on Monday, and if you don't have too many morning storms and they destabilize, they get sunny out there in Illinois, then Monday could be a significant tornado outbreak once again, because Illinois is the place to be this year. So anyways, thank you guys for tuning in. We'll be catching up later, and I will be out for Fox 23, so you can find my stream there during severe weather coverage. Thank you guys.